Welcome. This is an introduction to distributed computing. We will cover the fundamentals of distributed systems and why they're essential for big data processing. So, what exactly is distributed computing? It's a computing paradigm where multiple interconnected computers work together as a single system. This is done to solve complex problems and process large amounts of data efficiently. Let's look at the key characteristics of distributed computing. First, it provides scalability. This means you can add more nodes, which are individual computing units, to handle an increased workload. Second, it offers fault tolerance, meaning the system continues to work even if some of the nodes fail. This ensures reliability and continuous operation. Let's differentiate between centralized and distributed systems. In a centralized system, there is a single point of control and processing, meaning all operations are handled by one central server. In contrast, a distributed system involves multiple nodes working together, with processing and data spread across the network. This makes distributed systems more scalable and resilient. Why is distributed computing so important for big data? There are two main reasons. Volume. Distributed computing can handle massive datasets that exceed the capacity of a single machine. Speed. It can process data much faster through parallel computation, breaking down the task into smaller parts that are processed simultaneously on different nodes. What are the core components of a distributed system? First, there are nodes, which are the individual computers or servers that make up the distributed system. Second, there is the network, which is the communication infrastructure that connects all these nodes together, allowing them to share data and coordinate tasks. What are some common challenges in distributed computing? One is coordination, which involves synchronizing operations across multiple nodes to ensure consistency and accuracy. Another challenge is complexity, which arises from managing the system's intricate architecture and debugging failures that occur across different nodes. To summarize, here are the key takeaways. Distributed computing is essential for handling big data at scale, providing the necessary resources to process large volumes of information efficiently. However, it's important to balance the performance benefits with the inherent system complexity to ensure effective and reliable operation. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.